Hello there and welcome to Lower 6 Maths A-Level. This is the Applied Practice Paper I. Here we're working on question 5, a mechanics question. A ball is thrown vertically upwards with a speed of 16 meters per second from a point that is 80 meters above the ground. So let's just start this off by including this in our diagram. So we've got a ball here and initial speed of 16 meters per second upwards. Find the speed at which the ball strikes the ground. So let's take upwards as positive then. So S, U, V, A and T I think is in order here. So S, U, V, A and T. Now if you've done this question and checking your answer, and if you've set negative as the upward direction or downwards as the positive direction, then all of your numbers in this section here will just be negative. So don't worry if that happens. Okay, so S here, because it wants to travel 80 meters downwards, S is going to be minus 80. U is 16. We're not worried about we want to find the speed at which, okay, so that's V, so that's what we want to find. V is probably going to end up as a negative number because it's probably going to hit the ground going downwards. And acceleration due to gravity, so that's the acceleration that's happening here, that's always acting down towards the ground, so that's going to be minus 9.8. So in this case here, to link these four variables together here without time being included, we need V squared equals U squared plus 2AS. So let's substitute that all into the formula and square root it at the end. So V squared is going to equal 16 squared plus 2 times minus 9.8 times minus 80. So that would be probably a double negative there. V squared is therefore going to equal, we'll jump straight to V. V is going to equal then 43 meters per second. That 43 in terms of V is going to be downwards, so we're probably going to have a velocity here of minus 43 meters per second. But it does say find the speed at which the ball strikes the ground at, so we're just going to leave our final answer here of speed equals 43 meters per second. Okay, part B, find the total time that the ball is more than 85 meters above the ground. So that's from 5 meters above its initial position. So we're going to have, probably it's going to go up and then back down again. So it's probably going to be 2 times at which this happens. So we need to use the quadratic formula at some point. So what we need here is, so we need a distance here of 5 meters from above our initial starting point. U is still going to be 16. A is still going to be minus 9.8, and we want to work out the time. So the SUVAT formula we need here is S equals UT plus half AT squared, and substituting these numbers in here, we're going to get 5 equals 16t minus 4.9t squared, so I've halved the 9.8 there. Taking it all onto one side, and you get 4.9t squared take away 16t plus 5 equals 0. Substitute that into your quadratic formula, or use the quadratic formula button on your calculator, and we're going to get 2.915 and t equals 0.35. So find the total time that the ball is 95 meters above the ground, so it's the difference between these two times here. So t is going to equal 2.915, take away 0.35, and we're going to get 2.6 seconds. Okay. Find the greatest height the ball reaches sorry, so when the ball strikes the ground, so we strike the ground and the ball rebounds 1/5 of the speed that it strikes the ground at. Find the greatest height reached by the ball after it rebounds from the floor. So what we're going to need to work out here, we remember that V was 43 meters per second. So the rebound speed is going to be 1/5 of that 43 that we worked out earlier. So this is going to be 8.5-ish. So what's happened here is we've got the point here, it's gone upwards, strike to the ground, and now it's going to go back upwards and back down again. So we want to find this second maximum height on our diagram here. Now this speed that it strikes the ground at here is 1/5 of, well, this rebound speed is 1/5 of this speed here. So in our SUVAT equation, so we want to find its maximum height on the second bounce, after one bounce, sorry. So the initial speed here is going to be our 8.5 that we have taken 1/5 of 43 of. The final speed at this point here, well, it's going to be on the turning point of its velocity here, so that's going to be 0, and the acceleration is still going to be minus 9.8. So again, doing v squared equals u squared plus 2as. 0 squared for the final velocity, 8.5 squared for the initial velocity, plus 2 times minus 9.8 times s. So this is going to be 19.6 s equals 8.5 squared. So calculating this answer, grab your calculator, and you get 3.72. So 3.7 meters is that second rebound height. Okay, so that's 14 marks for that question.